Hi, everyone. It's a pleasure to be here with you today and talk about the challenges of moving the 5G core to the public cloud. I want to share some insights with you that I think as 5G service providers you should think about. As we know, it's a very hot topic and some 5G service providers have already made the plunge towards the 5G public cloud. First thing I want to point out is, the 5G core is more complex than any previous G that we've had. We now have 36 network functions identified in a 3GPP. If we want to move to the public cloud, we probably want to move the IMS core as well because of our fallback for voice. If we don't have 5G voice, is to the IMS core. And we now have user plane function separation from the control plane. So now we can distribute our control plane. So we have new capabilities there that we didn't have before with edge computing. We have network slicing that we didn't have before. And we have web scale capability with the cloud native software and basically building our own private telco cloud as a 5G service provider. And last but not least, we have the ability to bring Wi-Fi networks into the 5G core, wireline networks, or third-party non-cellular IoT networks into the 5G core. So we have a lot of options and capabilities that we never had before. Running a 5G network in the telco cloud is something it's kind of new, is to develop this telco cloud. And traditionally, we've had one centralized data center with the core network functions there. But now we can move the user plane function out to the edge or to the far edge, which I call all the way next to the RAN radio, radio site, because now we can have the lowest latency possible by moving it that far out to the edge. And our traditional suppliers right now, and when we look at just the 5G core vendors, is Huawei and ZTE. They're the leading vendors because China got off to a faster start with their build-outs over a year ago. All three Chinese service providers started building out their 5G standalone cores, and Huawei and ZTE garnered most of that business. And as a result of that, the investments by 5G core standalone revenues that we've monitored over the last year, Huawei and ZTE accounts for like 85% of that revenue. The other vendors there listed in alphabetical order. Cisco and Nokia got off to a quick start because of telco. T-Mobile USA with their 5G standalone network, Cisco doing the user plane function and Nokia doing the control plane function. Ericsson is getting Telstra and Swisscom up and ready to go. Mavenir is working on a few service providers they haven't named yet. NEC is working with Rakuten to get their 5G standalone network up and running. Ericsson and Nokia and Samsung are all working with the Korean vendors also, or the Korean service providers, to get their networks for 5G standalone ready and up and running. So we're going to see a lot more 5G standalone momentum going forward, but to date it's been pretty much dominated by the Chinese service provider market. So the thing that people are thinking about is, well, what about moving the telco cloud, if you will, to the public cloud? Traditionally we use the network function infrastructure supplied by the 5G core vendors. In the case of China, they relied on Huawei and ZTE's network function, or NFVI. That has been a traditional approach, but people say, hey, I'm locked into those vendors. I can now disaggregate the hardware from the software, which is true, and move it onto anybody's hardware. So the public cloud vendors are saying, hey, why don't you move it to our hardware and put it on our networks, and we can run it for you. And now you're not locked into one of those guys. So that's what's happening now, and the public cloud service providers are courting the 5G service providers, saying, hey, think about this as an opportunity for you. And here's all the benefits. And they do have a lot of benefits that they've identified that they've produced for the enterprise marketplace in providing public cloud services to enterprises. And I think we all know who the players are. The big three, Amazon Web Services, Microsoft Azure, and Google Cloud, control more than half of the market. And then we have the other players there in alphabetical order that we track at Dell'Oro Group in our public cloud services reporting market research that we do. So what are those challenges? We already touched a little bit on the complexity, and we'll talk a little bit in a second about time to market. And you can see the other items that we want to go over here in wrapping up with the total cost of ownership. I think Dish Networks has done us a favor by publishing their their vendors for their software for the 5G standalone network that they're building. And of course, I think we all know that they picked AWS or Amazon Web Services as their public cloud service provider, and they're trying to get all this software up and running on the cloud. From the 5G core perspective, we've got Nokia, Oracle, and Mavenir with the 5G core, and then you have the billing system, the charging system, the network security, and all the other sub-functions that go along with that, and also management software that all needs to be able to be integrated, work together on something that's never been done before. And Dish has decided to take that plunge and maybe get a head start on the market if this is something where the market might end up going. Now, in the case of Huawei and ZTE, they did end-to-end solution provisions for the Chinese service providers with pre-integrated, pre-tested software to get it up and running faster than maybe doing it something new like this. So if you look at the timeline that Dish has been on, they started their RFPs back in July of 2019, and they expect to launch in 1Q22. Now, they're being very cautious, careful, and pragmatic about this, because when you do something new, you've got to be careful before you go live. You do all the lab simulations you can, and now what their plan is in the fourth quarter to do their beta trial in their first city in Las Vegas, and try to get all the kinks, the bugs out of the system, so when they go, it's ready to go live in the first quarter of 2022. And anybody that's doing something for the first time will tell you it's very hard. You talk to Huawei and ZTE, how hard it was to get the 5G standalone networks up and running on day one in China. If you talk to the vendors that were helping get the 5G NSA or the non-standalone networks up and running in Korea when they were some of the first to launch, they'll tell you how hard that was to do. So it's not easy being first, and Dish Networks is taking the plunge. Now, the things that I look at from my experience is reliability and performance. Can the public cloud networks meet the performance of what I would call telco-grade network reliability? Back in the early days, at the beginning of the cellular business, I've been around since day one. I was the VP of sales for microwave backhaul, and these are the kind of network, the telco-grade network reliability. We actually had to design to 6 nines reliability, and it can be done, and no single point of failure in the network to give that complete reliability. You can't let the network go down. So can the public cloud network have that same type of service level agreement? And what they publish on their website is anywhere from 99.5% to 4 nines, and for the different various parts of their network. Now, I don't know if they have other non-published commitments that they will make to certain customer classes, government, military, telco service providers. That's something that you should be talking to them. Hey, what kind of network reliability can you provide me? System performance with layer 3 IP address forwarding is something that you need to talk to them about, because there's different ways of doing it. And the same thing with packet forwarding performance with software parsing or other techniques, because user plane functionality is going to be key to the performance of the network. And that impacts how many servers you have, how many CPU cores you have, how many cores you have. All that is impacted in the network function infrastructure. So you need to understand those differences to know what you're getting for your money. Also, how will the public cloud network react into the face of stresses that a telco network will undergo as workloads change from different times of days, different events, Mother's Day, an earthquake, and it puts a network under stress. A signaling storm happens because you got all these IoT devices all of a sudden going off. And how is the public cloud going to handle that, and how does it recover from that? Those are neat things to be understood, and of course you need to understand that from your other vendors that might provide you the telco cloud if you're not doing the public cloud. So right along with reliability and performance is geo-redundancy. As I mentioned, no single point of failure. But now it's not just a single point of failure that I can have my backup somewhere else. The backup almost needs to be it has to be geo-redundant. You can't have the same, you can't have like one backhaul transport network going to your point of presence that could take out both of them. And they can't be physically in the same location, because if something took out that location, it would take out both servers. But they have to be in if you will, in the same distance from wherever you're providing service if it's a latency sensitive point of presence. So it's not just hardware reliability and having a backup, it's where is that backup? And it has to be within the same circumference, if you will, to provide the same latency requirements that was there before. And then how does the network recover from a disaster? How does the bandwidth recover? How does the latency recover? And how does the edge recover? So all those things need to be thought about as you look at moving to the public cloud. Security is big on everybody's mind. Data sovereignty, things to think about. Can lawful intercept data stay in country if it's on the public cloud? Can it meet all the government regulatory requirements? Can you process all the signaling and data in country? And now you need to think about GDPR, which was implemented after the U.S. Cloud Act, and whether those two come into conflict with a U.S. public cloud service provider. So that's something that I think you need to work with your lawyers on that one to figure out the scenarios there. I'm not going to try and go there, but just wanted to point that out to cover everything. Agility and automation, absolute imperatives that you have an agile network so you can introduce new services as quickly as possible. So you don't get left behind where your competitor may have better agility. And you have to have automation, because none of this is easy. As we said, it's complex. And so the processes need to be automated so you can introduce those services as quickly as possible. So how are you going to manage your network when it's on the public cloud? You need to understand that ahead of time. What levers do you have? Which ones can you pull? Which ones can't you pull? Which ones do you have available to you? And how are you going to do your software upgrades? And then when you look at the management planes for service and infrastructure, are they independent of each other, or are they centralized, which provides more automated agility? Understanding that capability and those differences could impact your decision on which way you want to go. Vendor lock-in, very important to look at. That's one of the reasons we're looking at 5G public cloud, I believe. Several service providers say, hey, I don't like the vendor lock-in of the traditional model. I want my hardware and software disaggregated, which everybody pretty much does now. All the 5G service vendors have cloud native network functions that are independent of their hardware, and they can run on anybody's hardware. And they design it to work on all the different flavors of the public cloud service providers. So every service provider, they have to have a different build that works on it, because there's a little bit nuances between all the different public cloud service providers. So the thing to think about is, are you trading one kind of vendor lock-in for another kind of vendor lock-in? And how hard will it be to move from one public cloud service provider to another if they're not meeting your needs? If their performance isn't up to snuff, you're losing business because of it, and it's making it imperative for you to make that move. How hard is that move going to be and to get you up and running? And then you'll have to go back to your 5G core vendors and say, hey, I need a new flavor to go and work on that other public cloud service provider. And then the other thing to think about is when that public cloud service provider has downtime, in which all networks have downtime. I'm not picking on them in downtime. Telco clouds and telco networks, the traditional networks, have had their share of downtimes too. And it's not usually due to network reliability. They're usually due to some operator error, human error that takes place with the software glitches or whatever. It's not usually hardware that's going down, but there's been a couple of those where somebody's pulling the wrong plug at the wrong time. So everybody has some type of downtime. Nobody's perfect. But when it does happen, and hopefully it never does, but when it does happen, how is that network restored? The public cloud service providers have a lot of clients that they have to support. Who gets the support first? Do they all come up together? Do some clients have higher priority than others? You need to understand that ahead of time as to, hey, if you do, in unfortunate circumstances, go down, how do you bring the network back up and get it running? Total cost of ownership, things to look at, understand the change out for either one with respect to vendor lock-in. If I need to change network function NFVI, my NFVI for the telco cloud or for the public cloud, what's the cost of doing it on either platform to understand those differences? Looking long enough in the time horizons to be sure there aren't unexpected costs, because you're going to probably move from a CapEx intensive model to an OpEx intensive model. And what are all those costs going forward in time? Got to factor in the cost difference in performance if there are differences in their performance. Does it mean a certain target segment I can't go at because there's a deficiency in performance here, but the cost benefits for the rest of the market is hey, I'm attracted to. You need to make sure you factor those revenues in or out depending on which way you go. And then also make sure you factor in the cost of increasing the bandwidth and capability for compute and storage as the networks grow over time with new subscribers and new compute intensive and storage intensive applications, especially with video, predicted to continue to grow and grow and grow. So now I just want to close with one last tidbit. What about turning the paradigm upside down? Instead of adding the telco cloud to the public cloud, what about adding the public cloud services to the telco cloud? Now, in this case, the reason that a public cloud service provider might be interested in talking to a telco cloud and say, hey, I want to be able to add my services because you know what? You have all these 5G subscribers I want access to. Those are your subscribers. You own those. And they want access to them because they can't service these new applications, maybe for real-time applications that they can offer with their services because you own those subscribers and you own the edge. This gives you the opportunity now to monetize your network and enable public cloud service providers to offer their services for new low latency requirements that they couldn't do before. But they want to get to your subscribers. So this also enables you to have a multi-cloud strategy because enterprises are comfortable with working with one public cloud service provider versus another. They've chosen A, B, or C, and now you can offer A, B, and C and go to Enterprise A, Enterprise B, and Enterprise C and offer them the public cloud that they're used to working with so they can keep using the same design tools and everything that they have. So that's about a wrap there. We talked about the complexity, the time to market, reliability and performance is really important, making sure you understand the data sovereignty and the security issues, making sure you have that agility and automation that you need to stay competitive in the marketplace, make sure you understand the vendor lock-in issue either way, and trying to figure out with all those variables, what is the total cost of ownership over time. So I hope this was helpful. Oh, I just forgot to mention the multi-cloud strategy, telco cloud, hosting the public cloud services, if you will. That's the Verizon approach. So this is not an unprecedented thing. This is already happening with Verizon. So that is an option that's available to you as service providers. So I hope this is helpful, and thank you for your time.